Yo, 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 what's going on guys? Reese here from Stoic Pool, and in this episode of Learn Aiken, we're going to be doing a transaction counter. Let's get into it. Right, that's better. So I still haven't put up the acoustic foam because it's been Catalyst week, isn't it? So got the old trusty acoustic foam by here, just making like a little tent. So yeah. Right, so a transaction counter isn't too complicated. Basically what we're going to do is every time a transaction is spent, we're going to increase the number on a datum. And in order to do this, we're going to initially do it just counting the datum. So we just run the transaction and increment the datum. And then we're going to add an extra layer of complexity to something that's actually semi-useful, which is count the number of transactions that happen from a validator. Okay, I'm going to show you a quick diagram. Yeah, so you can kind of see what's going on here. We're literally just going to mint a token to a validator. We're going to test spending that transaction with the token in from the validator back to the validator. So it's not leaving, it's just doing a loop and increasing the count. That's the first step. Then we're going to add that extra layer of complexity, which is make another validator that people can deposit ADA into and other people or anyone can redeem from. The only way that you can spend from that validator is to include that token in the locking validator in the transaction so that it has to increment the count every time. Okay, that's it. Super simple. I'm sure you can probably figure this stuff out yourself if you have any experience with Aiken or any experience writing any smart contracts at all. It's not too complicated, but we're going to take you through it. This is a bit more beginner friendly than the last one, so let's dive right in. First step, we're going to make our new project. It's going to be called Counter. We're going to go in and we're going to create the Counter AK. Then we're going to copy Lucid in it into that validator, and we're also going to copy the wallets and our signing keys into that from our previous project. This is so that you don't need to create new wallets every time and pull ADA from the faucet, and it's just good practice. We're also going to rename our Lucid file to Counter. Getting started with the validators, we're going to make one validator called cmint. It's going to take a mint action, a script context, and return a bool, and we're just going to say true. And then we're going to make a cvalidator, which takes count datum, count action, and script context, and returns a bool. These are both going to be true. We're going to add parameters of the owner verification key hash, and to the locking validator, we're going to add policy ID. Then we're going to create our mint action, our count datum, and our count action, which are all just going to be an A field with an integer. Then we're going to make our verification key hash for our pub key hash, just so that we don't have to worry about doing these things later. If you watch the last video, you know I forget, so let's just get it done now. Next, we're going to do some imports because, as you know, I always forget to do the imports as well. So we're just going to add stuff that we're using right now, and then there's going to be less to mess around with later. We're going to try not to make too many spelling mistakes. So these validators are always succeeds. We're not even including the redeemer in this decision-making logic like we did in the last one. We're just going straight in. We're going to test these transactions and get on with it as quick as possible. We're going to minimize all these types because we don't really care about them now that they're made. We're going to import the hash functions, and we're going to run Aiken build. We've got no warnings, so we can check out our Plutus JSON file and check out what order the validators are in. We got mint first, and we got the locking validator second. Okay, so that's index 0 and index 1 respectively. Then we can go to our Lucid file, we can create our count validator, we can make it a spending validator, we can create our mint policy as well, so read count mint, and our count currency symbol. Remember, we got to do the mint first because we need to add the currency symbol or policy ID as a parameter to the locking validator. You're probably also wondering, like, Reese, what happened to your face? Well, there is a bit of a story there. I'm going to put it at the end of the video because I don't want to interrupt too much of the important stuff. So you can skip the chapters if you want and come back, or you can just find out at the end. Moving on, we go to our validator details. We create our redeemer, which is going to be a new constructor with a 1. And we're going to make our mint redeemer, which is going to be a new constructor with also 1. Then we're going to create the address for our locking validator using validator to address, and we're going to create the count datum, which is going to be a new constructor with a 0. Obviously, we need to do a 0. We're also going to create this burn redeemer, which we didn't do last time, and we really should because it's kind of good practice just using the testnet. Make sure you're burning stuff after you're done with it so you're not wasting any ADA or like locking it up indefinitely in random tokens for test purposes. So we're going to make sure that we do this. I'm sorry I didn't do it last time. The next step is to create our transaction execution function. So we're just going to copy this split UTXO. We're going to make a mint counter, which is going to mint the count token. and we're just going to put minted counter here and include the policy ID. And then we're going to do the same for our inc counter, which is going to be just incrementing the datum. We're going to call it inc count. We're going to say datum incremented or inked. We're going to include the inc count transaction hash and the policy ID. We don't actually need the policy ID here, but we're going to include it anyway. Now we can get on to drafting our transactions. We're going to do our mint count, and we're going to do an inc datum, and we're going to just make a new transaction, await Lucid, new TX, mint assets, attach the C mint minting policy, and pay to the contract C address with an inline C datum and a unit of 1. Then we're going to add our signing key, we're going to complete, and then we're going to do await TX sign and complete and return the submitted transaction. This will give us our transaction hash. Then we can make sure that we mint the unit assets with our mint redeemer. And because we haven't done it already, we're going to go up to the top and just add this unit, which is 2UNIT, and it's going to be the currency symbol and the token name. And token name today is going to be Salsa. Now we got that in place, we can do our burn count to burn the count token. And we're going to say burned counter, we're going to put the burn count transaction hash, and the policy ID we're just going to leave again. Then we can build a function, so burn counter, we're going to create a new transaction, we're going to collect from CUTXO, which we'll get to in a second, burn redeemer is going to be attached, then we're going to mint assets, we're going to put our unit and -1 with our burn redeemer. We're going to attach our minting policy, CMint. We're going to attach our spending validator, CVal, and we're going to add our signing key and complete. Then we're going to sign and we'll return submitted transaction to get the transaction hash. There's a couple of extra things that we need to do here. The first one is to get the UTXOs with the unit from the validator. So C address and attach unit. Then we're going to get the first UTXO, there should only be one. We're going to console log the address just so we can see where it's going and just, for a little bit more feedback to make it a bit more interesting. And we're good to go. We can comment these out and we're ready to run our mint transaction. So we're going to do dino run and we minted our counter. We're going to comment that out and we're going to immediately try burning, which was also successful. Now we can check out these transaction hashes. You can see Salsa 1. And in our burn transaction, you can see Salsa -1. So we've managed to mint a token and burn it, right? We make sure we can do both sides of the coin before we move on to the next step. Next up, we can focus on our count transaction. So we're going to create a new transaction, UTX. We're going to collect from the CUTXOs. If you remember, redeemer is going to be attached. We're also going to attach the spending validator, CVal, and we're going to pay to contract C address with our inline datum C2 with the single token. We're going to sign, we're going to submit, and to run this transaction, we need the UTXOs from C address with the unit. And we're going to get the first one because, again, there should only be one. We're going to check what the datum is with data from CUTXO.datum. We're going to get the count from the first field, index 0. We're going to add 1 to that count to create our out count variable. And then we're going to put that into CDatum2, which is a data2 new constructor with the out count. We're going to console log that out count so that when we run the transaction, we can actually see what the new count will be. So now we're going to test our inc transaction. We're going to uncomment everything. We're going to run our mint, which was successful. Then we're going to run our inc transaction and we got an error. Now, the reason we got this error is because I made an oopsie. We got to make sure we submit and we can run it again and the datum was incremented. You can see there that the out count was going to be 1, which is the new count after we've incremented the original datum starting from 0. So that means that's working correctly. We can go and check this transaction. You can see one Salsa token goes in, one Salsa token goes out, and you can see the change in the datums here. Let's try it again just to see if it works. And so we run the transaction again and we see 2, and then we run it again and we see 3. So now we know that every time we're running that transaction, the datum is incrementing, so it is counting. Next, we're going to run our burn transaction, and you can see there, burned counter, fantastic. We check the transaction, -1. So now we see that our transactions work with our always succeed script. We can start incrementally adding more logic to the validators and just keep iterating those tests. We're going to start with our mint policy, obviously. We're going to get the transaction and the purpose from the script context. Then we're going to get policy ID with our mint purpose. We're going to say let transaction, we're going to get mint outputs and extra signatories from transaction. And then we're going to expect a count name and a count amount. We're going to extrapolate that just like last time from minted value, tokens of policy ID, and turn it into a list. Then we're going to add our check to make sure that it's signed by the parameterized owner. Just like last time, this is so only the owner can mint and burn those tokens. We don't want to let anyone else do it because otherwise anyone can come along and mint those tokens. We're going to say when RA, the redeemer field A is 1, it's going to return true, and otherwise it's going to return true. We've done this before, so we know it works. So what we're going to do is we're actually just going to assign some logic to each of those redeemer cases. For 1, we're going to say count amount equals 1. For anything else, count amount equals -1. So now you see the purpose of the burn redeemer. It's 2 instead of 1, so that's any other case for the validator logic. So whenever we use that burn redeemer, it's going to make sure that we're burning a token. Only when you have a redeemer value of 1 is it going to check for a mint. Okay, so we run Aiken build, and then we run our mint transaction. Mint counter worked. We'll switch to burn, and we've burned. Now we know both of those cases work with the different redeemers, so we can move on and add a bit extra logic. So instead of just checking for account amount, we're also going to check the outputs. Last time I did expect list any, but any returns a bool anyway, so expecting it was kind of pointless. So we're going to say any outputs, and then we're going to expect in that output an inline datum, and that datum is going to be a count datum. And then we're going to say quantity of with the output value, policy ID, and the count name is 1. Then we need to do a couple of silly imports because obviously I forgot. And we're going to build, and then we can run our transactions. Mint worked, and then we returned a problem. And that's because we're basically similar to last time. We're just trying to run all the transactions together. And you can see here, it says insufficient collateral. So it's spending like a really big UTXO, and then it hasn't returned back to the wallet in time for you to use it again. Silly old Reese. But it worked. And then the next one also works. Again, we had this insufficient collateral problem. So we run the transaction again and we burned. So this means that the minting validator works perfectly fine. We don't really need to add any more logic. I mean, there's no point. We make sure that there's 1 minted or 1 burned. And if it's minted, it has the appropriate datum. That's it. Now we're going to move on to the locking validator. We're just going to say when the redeemer is 1, it's true, otherwise it's true. We're actually going to change that straight away to make sure it's signed by the owner because we know what that is by now. We're going to get the transaction and purpose from the script context. We're going to make sure it's spending, and we're going to get a couple of fields out of the transaction that we're going to need. Now we're going to draft out our logic. So there's a couple of things that we need to check for that we already kind of know we need to check for them. And that is that the input contains the policy ID and the output contains the policy ID and increments the count in the datum by 1. Oh, and we need to make sure it's our own output. So we're going to expect some input. We're going to find input with our own reference. We're going to get the fields from that input, and we're going to get our script hash by accessing the address payment credential field. Then we're going to say let in is values of tokens of input value with our parameterized policy ID. Next up, we're going to do our output. So we're going to say script outs is find script outs, and we're going to stick the outputs in and attach our script hash, which we've already found. Then we're going to expect some output. We're going to get ahead of our script outputs. There should only be 1. Then we're going to check the output for the amount of our policy ID. And we're going to say head of in and head of out because these return as lists. So we can't check a list against a list. We need to check the values in the list. There should only be 1 because there's only 1 token with the policy ID. And so it should just be a 1. And we're going to make sure that inputs and outputs are balanced with our policy ID. So that means every time we spend, the input from that validator has to spend that token back to the validator. It has to be in that script output. Okay, so now we can run our script. Mint counter was successful. We're going to try our increment. That was successful. And then we're going to burn. We don't really need to keep checking these transactions. It's working, so we know that it's working because we've already checked this logic. So as long as that comes up, that means it's good. The one thing we didn't do is we didn't check the datum was increased. So now we're going to do that. We already have our input datum because it's part of the transaction. So what we need to do is basically say that datum A is equal to DA. D is the input datum. So datum A is the A field for the output datum. Well, we'll create that in just a second, but just so you follow what's going on. We're basically saying that the output A field equals the in A field plus 1. So it has to increment by 1 if it's being spent. To write that logic, we're just going to expect an inline datum from our output, and we're just going to make sure that it is a count datum. Right, so now we got that in place, we can run Aiken build and we can test the transactions, and the mint was successful. and the increment was successful, so we're just going to burn the token. So that is the first phase, right? We've got our count, we've got it incrementing, and every time you spend from that validator, it has to be sent back with the datum count increased by 1. So that's the first phase. Now we can start moving on to the next layer of complexity, which is to count a different validator's transactions. You might be thinking, like, why don't we just put a count on the datum at the validator? And the reason is because anyone can push transactions to a validator. So counting a transaction there will only count if that specific transaction is spent back to the validator. Otherwise, it's not going to work. What we actually want to check for is that every time there's a transaction spent from the distribution validator, the locking validator is included, and that's how the count is incremented. We're going to make a new validator. We're going to parameterize it by our owner and the policy ID. And we're going to call it distro, just like last time. We got this datum, we got this action and script context, and we're going to return a bool. Then we're going to extract the fields from the script context. We're going to make sure it's spending, and that'll get our own reference. Then we can get a couple of fields out of the transaction. When redeemer A is 1, we're going to check for any outputs that have the policy ID. So there's only going to be one of those tokens. So the reason we do this is because we want anyone to be able to withdraw from the validator. We're not trying to stop people from using it. What we're trying to do is every time that validator is used, we're going to increment the count. So we keep track of how much that validator is being used. Otherwise, we're going to say the transaction has to be signed by the owner. So we'll look at that quickly again. If 1, there's an output with the policy ID, and otherwise the transaction's signed by the owner. We're going to add a couple of extra imports. We're going to also make our disDatum and disAction and correct the spelling mistake. Next up, we're going to create our transaction execution functions. We're going to have one called makeDeposit or deposit, which runs the makeDeposit transaction. And we're going to do another one that's withdrawal, and that's going to make the withdrawal. And both cases, we're just going to return the transaction hash so that we can check it. Then we can build our transactions. We're going to make deposit, and that's going to be a new transaction. We're going to collect from UTXOs. We're going to pay to contract D address, which is the distribution address, and we're going to add D datum, and we're going to say it has to be 100 ADA. We're going to put complete. We're going to sign the transaction, and we're going to submit it. Then to get this information, we need to get the UTXOs from the wallet. And we need to get D address, which we don't have yet. So we're going to get back up to the top. We're going to import our distribution validator by creating our read validator function. We're going to add the parameters and the correct index. Then we're going to make our D address value, which is a validator to address distro. And we're going to create our D datum, which is going to be a new constructor with a 1. This doesn't actually matter, but in order to spend from a validator, it has to have a datum. So we need to include something. So we'll just chuck that in. Now we can make our withdrawal transaction. So we can say await Lucid new transaction. And what we need to do is we need to get cval UTXOs with the counter. We need to get the UTXOs from the distribution validator. We need to increment the counter and return that token to the lock-in validator. And we need to send the value from the distribution validator to the beneficiary. So we're going to say collect from CUTXO with redeemer, collect from UTXO with redeemer, attach the C validator, attach the distribution validator, and pay to contract C address with the new datum, which we'll get to in a second, and the token. Then we're going to pay to address, and we'll just pay to the beneficiary address, and we'll give them the 100 lovelies. So to create all that information, we got CUTXOs, and we're going to await the UTXOs with unit from the C address. We're going to get the first UTXO in that list. Again, there should only be one. Then we're going to get the UTXOs from the distribution validator. We're going to get the first one from the list, and we're going to create our new datum by getting the datum from CUTXO. We're going to get the count, we're going to increment the count, and we're going to create our new datum with our new count in it, exactly like we did before. Console log that just for our own interest, and we'll sign it and we'll submit it. Okay, then we can run our transaction. The mint worked, so that's great news. Then we're going to try our deposit, and we got caught because we didn't await it. Deposit made, perfect. Then we're going to try our withdrawal, and the count worked, but there's a problem. I forgot to add complete, so run it again, and the withdrawal's made. Fantastic. We'll try it again, so we'll run our deposit, and then we'll run our withdrawal again, and we can see the count increases, so now it's 2. So this works fine. Fantastic. Now we can burn it. In the real world, we don't control what UTXOs are available at the validator because anyone can send stuff. So in this, I got the head of the list of the UTXOs at the distribution validator, but actually we shouldn't. We should just attach all of the UTXOs and let Lucid figure out what ones need to be included to make the proper value be redeemed. And the last step, as always, is just to remove all the comments to tidy up the validators a bit, and we're finished. Right, so I hope that wasn't too complicated for you. I think we brushed through it a lot quicker than the last one because there was a lot less explaining to do. And if you watch the last one, it should be much, much easier to follow than the previous example. This is much more beginner friendly. And we checked 2 versions as well. So the first one, we just checked that we could increment the value at the datum. And then the second one, we actually gave it some real purpose. And although this isn't really anything you would particularly want to do, there are use cases for this, such as minting NFTs, for example. Like maybe you want anyone to be able to redeem an NFT up to a certain value, or maybe you want to use that count as a number for the series of the NFTs, or something like that. There are problems with that as well, which we'll get into in another video when I show you how to do an on-chain whitelist. We'll save that till next time. Don't forget YouTube stuff. Do all the YouTube stuff, like, comment, share, blah, blah, blah. And I'll catch you in the next one. See you then. I almost forgot, I haven't told you how I got these scars. So last night we were doing a little salsa with the missus, having a great time with the fiance, and all of a sudden... and that is exactly how it happened.